Alright, hi everyone, welcome to my YouTube channel, City of Electrons. So in this video we are going to do this example of vector calculus. The last video we talked about vector calculus. Okay, so in this video we are going to work an example on it. So now let's say this is a force, okay, and the force is defined by this and this and this and this and this and this. So assume F is a force. What is the work done in moving from point P2, and these are the coordinates of P2, to point P3 in the figure below? Okay, so to move from here to here, and this point is defined by this coordinate 5 0 x y. So x is 5, y is 0. Then point 3, x is 0, y is 3. Point 3, x is 0, y is 3. So we have to calculate the work done. And then does the work depend on the path taken by P2 and P3? Okay, so now solution. So for the A part, note that this is considered, we are dealing with 2 dimensions here. The x dimension, change in that x dimension, and then the y dimension. And we denote that with what? This. So since we are looking for work done, it's like saying force times distance. Okay, force times distance. So just as take it in that format. Now from one point to the next, okay, from P1 to P2. Now this is for the force, which is the value we have right here. Okay, remember work is what? Work is force times distance. Okay, so this is the force, and this, consider this a what? In the x direction, and in the what? Y direction, these two. Now when you taking dot product, when this, let's see if we can use this part, taking dot product now. Oh, we've done this already, that when this dots this, same thing, same direction, dot each other, you get what? 1. So this dots this will give you what? 2x, just like, bring it closer. So this dots this will result in what? This will be 1, and this will be what? 2dx. That's this 2dx plus, now this dots this, because these are in different direction, you get what? A 0, and that 0 will cancel out this term. So the next thing to do is what? This guy, this dot this. Now these 2 are in different direction, that will give you a 0, so this term is out. Then this dot this, these 2 are in the same direction, that will give you 1, so you have 2y dy. So that's why we have this. Okay, so I hope that's clear enough. Alright, so what happens next is this: 2x dx plus 2y dy from P2 to P1. Now we can actually separate this thing. Saying 2x dx, we say we are moving from x towards x. Then plus, we integrate this thing. Did I say differentiate? Please integrate. Then you now, so it's like saying that the integration will deal with this. Integration will also come and deal with this separately. From x to x, that's from x1 to x2, y1 to y2. And we can see from the diagram that for x, the x1 is what? 5, x2 is what? 0, y1 is what? 0, y2 is what? 3. So that's how we have it like this: 5 to 0 for x, 5 to 0 for x. For y is what? For y, 0 to 3. Look at it. 0 to 3. Are we seeing it? So now we can go in and then integrate this guy. When you integrate 2x, you get what? When you integrate 2x, that gives you what? 2x squared all over 2. And of course, this we cancel this. So what you have left is just what? 2x. Same thing, 2x. Same thing to this y. You have what? 2y squared over 2. For y, for 2y, you have, when you differentiate, you have what? Y will be squared over 2. This will cancel this. So you have this left. So that's what you have here. And then the boundary term, 5 to 0, 5 to 0, 0 to 3, 0 to 3. So when you substitute that, the upper limit 0 squared minus lower limit 5 squared, upper limit 3 squared minus lower limit 0 squared, that will result in this, and you get this as your final answer. Okay, so that's just an example on the vector calculus. There are more, there is a lot to do on this. Okay, however, this is a class recap and we'll just stop here. And okay, so we'll see you in the next video. All right, thanks a lot for watching. Bye for now.